Okay, Assalamualaikum and very good morning. So today we have gonna learn about energy method, and energy method also we call as unit law method and also virtual work method. Right. So at the end of the lecture, you will be able to use this method to obtain deflection. Okay, determine the vertical or horizontal displacement. Displacement means if there is any load, so this structure will be bent. Okay, so this one we have to find out what is this displacement at this point. Okay, this formula you have to memorize, right? So this method defined as method to use to determine the displacement. Truss joint, when the truss is subjected to external loading, temperature change, and fabrication errors. But for your syllabus, you are only focused on external loading changes. Okay, this formula is 1 kilonewton. Actually, this one is 1 kilonewton times displacement. Okay, equal to total of, this one is come from virtual forces. This n is real forces, length of members, area, and E is modulus of elasticity. Right? I don't want to focus on these procedures. We go to the example number 1. So first, when you get this question, need you to find the vertical displacement at joint C. Okay, and given the area is 400 millimeter squared and elastic modulus elasticity is 200 gigapascal. First step, you have to find the reaction. Okay, so you have the AY, AX, BY, and BX. BY. You don't have BX, only BY, so because this is rolling. And then you have to find out real forces. N, capital N. Okay, these real forces you can use methods of joint. So as usual, you have to find out, you have to pick member that less than 2 members. So you can pick A or B. You may start from A, B, or C because these three points have less than 2 members. So join A, you do the methods of join, and join B, you do the methods of join, and join C, you do the methods of join. With this 4 kilonewton at this horizontal, 4 kilonewton have at this point, right? And then third step, you have to find the virtual forces, small n. This small n you have to use methods of join too. But you have to refer to the question. So question need you to find the vertical displacement of joint C, vertical displacement. So the vertical means this direction or this direction, you may choose either one and put 1 kilonewton. Right, so you draw a new free body diagram with this AY, AX, BY, and vertical displacement at joint C. So I choose this direction, 1 kilonewton. It's okay if you choose upward. Okay, also true. Also can. Alright, from this free body diagram, you find out the reaction, new reaction. Okay, this reaction, you have to find out new reaction. You find out what is AY, AX, BY. Okay, what's the value? And then you use methods of join and then cutting this join A, join B, or join C. So join A, join B, and join C using methods of join. Then last, okay, using this equation. Okay, so by using this equation, you have to make a table. So we do a table. Okay, table U. So you have a members. Okay, members is AB, AC, OBC, AB, BC, AC. Alright. So you have found out the real forces, this big N. Okay, using the methods of join, what is AB value, compression or tension? You put this here in kilonewton. So this small n in kilonewton. Okay, this length, so length AB is 8 meter, length 8 in unit meter. BC is, you have to calculate BC length. Okay, using theorem Pythagoras. Okay, theorem Pythagoras. So what is BC? Right, so you have to find out this length. Area given all each members is 400. Okay, so cannot, no need to put A here. E also similar for the whole diagram, 400. So if you refer to this formula, there is a N, small n, big N, and L length. So you multiples all these value. This value, you multiple with this value and this value. So you get this value right here and then total up. And then by using the equation 1 kilonewton times delta at point C. So delta C is equal to total of N and L, this total, okay, you put here, divided by A, area here, and E, this E, put here, right? And then you will get the vertical displacement in meter or millimeter. Okay, so we go to the slide, next slide. Okay, this slide, okay, Okay, for this slide, he does the vertical visual forces first. Visual forces mean uh, small n, so it puts 1 kilonewton, and then get the value of visual forces by using methods of join at AC negative 0.833 kilonewton. Okay, so AB 0.677, BC negative 0.833, and for real forces means this 4 kilonewton is here, and then do the methods of join and get the value of AB 2 kilonewton, AC 2.5, and BC negative 2.5, right? And then you use a table, right? Put the value carefully, and then with the length calculate by yourself, and then times this value 1 2 3, so 1 times 2 times 3. Okay, right, times 1 times 2 times 3, and then you get the total here, and then you use this equation that you remember previously. So you put the value of n here, n and l here, so A and E given. Okay, so I will show you the conversion units for this equation. Okay, so for example, from this equation, right, conversion, how do you get this meter and millimeter? Okay, so 110.67 kilonewton squared meter. Okay, this A is millimeter. Okay, bahagi divide by 400 millimeter squared, right? So 1000 millimeter is 1 meter. So this squared, so this one squared, 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 right? And then bahagi this one 200 gigapascal, so 200 giga is power of 9, pascal is newton per meter squared. Okay, so the cutting it out, so you get this value in meter squared, and this value is newton, this one is kilonewton. So this kilonewton, okay, this one convert into kilonewton. Okay, so 1000 newton is 1 kilonewton, right? We use kilonewton, alright? So newton cutting out, so you get this value in kilonewton meter squared, this one this value in kilonewton squared, so same unit, kilonewton. So we have same unit, kilonewton, meter, kilonewton, meter, right? Then last we get the value in meter, 0.000133 meter. Okay, what I want you should do for this time, alright, so you have to do the example number 2. Okay, so from this question Okay, there is a B, C. This one is pin support, this one is roller support, so you have to do the reaction AY, AX, and then this one is BY. Okay, question given is horizontal displacement of joint C. So horizontal displacement at joint C, this joint. So first you find the reaction. Second, you find the real forces. So real forces, this one is real forces, okay, diagram. This one is real forces diagram. So you have to find out what is the value AY, AX and BY if there is 40 kilonewton and 20 kilonewton at joint C. And then third, you using a methods of joint. Find out joint A, joint B and joint C. What is the value of this member, compression or tension? Alright, and then you do a visual forces. Okay, so for visual forces, given in this question is horizontal displacement at joint C, so horizontal can be like this one, 1 kilonewton, or this way, 1 kilonewton. Okay, so you may choose either one. So 1 kilonewton here at joint C, and then maintain the support EY and AX, BY. So find out the reaction and then do a visual forces for this visual forces diagram. And then you do a table. And then lastly, using a formula, C is equal to changes of N and L over AE. Okay, this one is real forces diagram. This diagram is real forces diagram. And big N. So this one is visual forces. Okay, visual forces. So given this value, you get 0.5, 0.625, negative 0.625. And then you get the real forces, 36.67, negative 16.67, negative 45.84 kilonewton. Right, and then put in the table. Right, get this N and L total, and then you get the vertical, question need you to find horizontal displacement. Alright, so horizontal. So this one is horizontal, not vertical. Okay, horizontal. Horizontal displacement, you get this value. Right, so you get 0.0068. You can put 0.007 meter. It's okay. Alright, so this exercise, I want you to do this exercise and submit this exercise at UFuture by today. Okay, so first, this question need you to find vertical displacement at joint C. So you can use this direction or this direction, 1 kilonewton at joint C. The cross-sectional area, given area and E 200 gigapascal, area 300 millimeter squared, this one 200 gigapascal. So same, you have to use a reaction. You find out the reaction for the real forces. This one is real forces, and then by using methods of joint, find out each member ni, what is the forces, either compression or tension, what is the value, and then okay. So and then you have to use this one. I make for you visual forces, that free body diagram. Okay, this one. So you have to use this one, 1 kilonewton at this point. Okay, so find out the reaction, and then by using methods of join, find out the forces in this diagram. AF, AB, what is BF, and then we do a table, and then using a formula of mutual forces, energy method. So this one is the answer. So you have to submit this exercise in the future. Okay, by today. Thank you very much.